Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper trending on X, published on December 9th, 2025, about 6 days ago. It introduces EgoX, a system that can turn a single third-person video into a realistic first-person experience, filling in all the unseen parts of the scene in a way that still makes geometric sense. The paper is titled EgoX, Egocentric Video Generation from a Single Exocentric Video. And as we will see later, the approach squeezes surprisingly strong performance out of a lightly adapted video diffusion model. Alright, Figure 1 gives a concrete taste of what EgoX does. The top strip of frames shows the classic third-person shot of the Joker walking away from the exploding hospital, which acts as the exocentric input video. The bottom strip then shows the synthesized egocentric view, with a circular, head-mounted perspective and the Joker's hands and detonator in the foreground. This contrast highlights that the method must both invent the unseen body and maintain consistent scene geometry across time. Well, Figure 2 spells out why the problem is so tricky. The left exocentric video panel shows a wide third-person view where most of the kitchen, outlined in blue, is unrelated to what the future Ego camera will see. The smaller yellow region marks areas that are only partially related to the eventual first-person view. The right egocentric video panel highlights in red the uninformed regions that the model must hallucinate realistically while still preserving geometry and objects that are actually visible. Alright, while Figure 2 highlighted how much must be hallucinated, Figure 3 explains how the system actually does the conversion. The left side shows the exocentric video being lifted into a three-dimensional point cloud, then rendered into an egocentric prior video along a planned ego trajectory. The middle block encodes both videos into latents that are concatenated widthwise and channel-wise, so the model sees global context and pixel-aligned guidance together. The right block applies geometry-guided self-attention inside the video diffusion model, and finally decodes a coherent first-person ego video. So, while Figure 3 outlined the whole conversion pipeline, Figure 4 zooms in on the geometry-guided self-attention block itself. The left side shows the exo and ego videos passing through a shared encoder and decoder, with a special attention module sitting inside the diffusion transformer. The central matrix panels depict how ego queries and exo keys interact, with colored tokens receiving weights scaled by a geometric factor based on three-dimensional direction similarity. The right side visualizes this in the reconstructed point cloud, where blue-red ray pairs that align in direction get boosted, while green-orange pairs that point in opposite ways get suppressed. Alright, Figure 5 shows how the method visually stacks up against several baselines across seen scenes, unseen scenes, and in the wild footage. The top band compares kitchen and training scenarios, where the circular egocentric views from our method keep objects stable and realistically placed over time. The middle band with basketball and outdoor clips demonstrates better geometry, since hands, tools, and floors align with the exocentric view. The bottom and the wild examples highlight sharper details and fewer visual glitches than the competing camera control models. So, after those visual comparisons, Table 2 summarizes how much each piece of the system actually matters. The full EgoX model achieves the strongest overall scores on image, object, and video criteria, which means the generated first-person clips are both sharp and temporally stable. Removing geometry-guided self-attention slightly hurts all metrics, especially object location accuracy. Dropping the egocentric prior or the clean exocentric latent degrades things further, with higher video distance and worse motion quality, showing that all three components are critical together. While Table 1 steps back to compare EgoX against several baseline methods across both seen and unseen scenes, the left columns list scenarios and methods, while the central image and object criteria show that EgoX consistently achieves the best or second best scores, meaning sharper, better aligned frames and objects. The right video criteria block reports Frichet video distance and motion metrics, where EgoX again leads overall, despite WAN versus ACE, sometimes scoring well because its outputs stay nearly static. Overall, the numbers confirm that the method is both visually accurate and temporally coherent. EgoX shows that a lightly adapted video diffusion model, guided by a rendered first-person prior and geometry-aware attention, can turn a single third-person clip into a convincing egocentric experience. That unlocks new possibilities for immersive training, robotics, and film. That is it for this episode of AI Research Roundup. I am Alex. Thanks for listening.